On our last video, we had set up number 6 on the bottom of page 7 in our 7.2 notes. We determined that it was a Pythagorean theorem problem because the building is built on a right angle and we have two sides and we're supposed to find the missing side. Since we're finding the missing side, we use Pythagorean. So these are A and B, and remember the side opposite the right angle is always C. So it came to be x squared plus 18 squared plus 2x plus 6 squared. This is another common one you'll see in 150 quite often. So let's do the left side first. So we need 18 squared, which is 324. So we'll have x squared plus 324 equals, and this is where you have to be careful. A bunch of you missed this problem in chapter 4. 2 terms squared means FOIL. So we have to write 2x plus 6 times 2x plus 6. So this is x squared plus 324 equals, foiling, we get 4x squared from first, outer plus 12x, inner plus 12x, and last plus 36. So as you can see, this is an ugly problem. So this x squared tells us that we do need to have it set equal to 0 because we're either going to have to factor if it's factorable or use quadratic formula if it's not. And this gives me the hint that it's a quadratic formula problem because when we factor, we get nice numbers. When we have to round, that usually means quadratic formula. So since either method requires that we have it set equal to 0, the largest x squared's there. So let's go ahead and bring the other stuff over. So minus 1x squared minus 1x squared. And then we need to bring this over, minus 324 minus 324, and put it underneath its like term. So let's go ahead and switch over to, I had a piece of paper here, to the other side. So you're going to see quite often we're going to have to go to another sheet of paper. So this is one of those times. So I'm going to pick up from here. So now I'm going to have 0, and this is number 6 of 7.2 notes. On page 7. So this side's going to be 0. So we're going to have 0 equals, and on this side we're going to have 3x squared. And then we have two like terms here. 12x plus 12x would be plus 24x. And then let's use our calculator on this last part. 36 minus 324. So 36 minus 324 is negative 288. So that's for this right here. So the first thing I do is I go, oh my goodness, these numbers are huge. But then I think to myself, oh, I'm supposed to look for a GCF when I see the numbers so huge. So let's see. This is divisible by 3. This is divisible by 3. Add these digits, 16, 17, 18. Yep, that's divisible by 3 too. So we can at least take a 3 out of everything and make either our factoring or quadratic formula a lot nicer. You just have to make sure if you're going to take something out, it's all the way across every term. So then we get, I'm going to flip it over, 1x squared plus 8x minus, and we have 288 already in the calculator, so let's just go divided by 3, and that gives us negative 96 equals 0. So we could try for factoring, shall we? 1 and 96, that obviously doesn't subtract to 8. 2 and 48, that doesn't subtract to 8. 3 and 32, that doesn't subtract to 8. 4 and 24, no, getting closer though. 5 doesn't go into it. 6 and 16, I believe. Let me just make sure. 16 times 6. Yep. That doesn't subtract 8, but we're getting real close. Let's see if it's divisible. 96 divided by 7, because there's no trick for 7. Nope. 96 divided by 8 is 12. So 8 and 12. Nope. That doesn't subtract 8. And see how we passed it up? This has a difference of 10, and this has a difference of 4. That means we can't find 8. So if you do everything in order, you can tell when it's not going to happen. You subtract these, you get 10. You subtract these, you get 4. And we need 8. So we passed up 8. Not possible. So that means we have to use the quadratic formula, which I told you from the directions. I probably should have went straight there, because this tells me it's a rounding problem, and we don't round during factoring, but with quadratic we do. So we have, focus here, A equals 1, B equals 8, C equals negative 96. So now you can see why we have to have the quadratic formula, because some things don't factor. There's no factors of 96 that subtract to 8. So plan B, quadratic formula. So let's write it again. I think this is about the 5th time we've written it, so that's good. Opposite of B, plus or minus square root of B squared minus 4AC all over 2A. So now we need to plug in. So x equals, opposite of b would be negative 8, plus or minus b squared would be 8 times 8, 64, minus 4 times a, which is 1, times c, which is negative 96. All over 2 times a, which is 2 times 1. So this time, we don't have to simplify the radical, because this is a calculator problem, since it said round to the nearest, was it 10th? Yeah. So we do have to punch in the calculator and figure out what this is, but then we don't have to simplify the radical by finding pairs or anything, since it's calculator. So let's get it ready for the calculator. So negative 8 plus or minus empty square root over 2. So on the calculator, don't type in the radical again, just type in what you're going to be doing. So 64 minus 4 times 1 times negative 96 is 448. Whoa, aren't you glad we don't have to simplify that? That would be a big tree, I'm sure. So this is how we find our possible solutions. We list our 2, negative 8 plus square root 448 divided by 2. Or it could be, and usually one makes sense and one doesn't, so we'll see after we get our 2 answers. Square root 448 divided by 2. And this one is asking us to find the length of the ladder. So after we get x, then we have to plug it in. Ugh. Ugly, ugly, ugly. Yep. So after we find x rounded to the nearest 10th, then we have to plug it in here to find the length of the ladder. So, wow, good thing we're not in class. Class time would be up by now, huh? So, this is a trick. So pay attention here. At the end of the line, you have to hit enter. If you divide by 2, it just takes 448 divided by 2. It doesn't take the whole line. So after you type the numerator, hit enter, then divide it by 2. Same thing here. Type the numerator, hit enter, then divide it by 2. And remember, we're rounding to the nearest tenth. So it'd be -8 plus, and then we do second x squared, which is the square root key, and that would be 448. Close your radical, hit enter. So on your paper, and hopefully you're doing this on a separate sheet too, so that you can look back at it later to remind yourself. And then after we hit enter, so see how we've just done the numerator, then we divide by 2. So rounded to the nearest tenth, does everybody agree? That'd be 6.6. And it is approximated, so when you go to write it down, make sure and use your approximation symbol, 6.6. Now we need to type in the other one and see what we get there. So clear, this one would be -8 minus second x squared, which is our square root, 448. Close your parentheses to tell the calculator you're done with the radical. Hit enter, and then divide it by 2. And that is -14.6 rounded. Okay, time to go back to the other side. See what x is? X is the side of a triangle. So do both of those answers make sense for x? No, this doesn't, right? I can't have a triangle -14.6 feet. So cross that one out. So take your 6.6, and we're going to write that here. X is approximately 6.6. But since this problem is never ending, they're trying to torture us. Now we have to find the length of the ladder. So we need to put that 6.6 right in there. And then over here, we'll write length of ladder. So approximately, show the reader it's not an exact answer because we rounded. So then on our calculator, we type this in. 2 times 6.6 plus 6. So the ladder's approximately 19.2 feet long. So we just put our 6.6 in there, type that in, 19.2 feet long. Because it says find the length of the ladder. So that, my friends, is a very long problem. Okay, one more to tackle. This one's not so bad because I remember doing this in class last semester. So let's go ahead and look at number 7. 7 is another one you're going to see a lot in the next class. I call them picture frame problems. Lots of times they're going to be gardens. Sometimes they're a rug. They're something that has a uniform border around the top, around the outside. So picture frames have it. If you have a sidewalk around your garden of uniform width, something like that. But they generally look like this. So let's read through and start filling it out, and then we'll have to finish on the next video. A rug is to fit in a room so that a border of even width. That is the key. So you need to know that means this is the same as this, is the same as this, is the same as this. So all the way around it's even width. The room is 15 feet by 25 feet. So 15 feet by 25 feet is the room. And the area of the rug, so let's write that here, area of the rug is 119 square feet. So 119 feet squared. How wide will the border be? So that's what we're going to call X. And we'll pick up from there on the next